Hello guys, welcome to all of you. Let us see a question. In this question, it is said that in the circuit shown below, both the enhancement mode and MOS transistor have the following characteristic. Kn value is 1 milliampere per volt square. So Kn value for these two NMOS transistor is given as 1 milliampere per volt square. And threshold voltage of this NMOS transistors is given as 1 volt. Assume that the channel length modulation parameter lambda is 0. Lambda value is given 0 in this question, and body is sorted to 0. So body voltage VB voltage is given as 0. The minimum supply voltage VDD in volts needed to ensure that transistor M1 operates in set mode of operation. So we have to calculate the value of VDD for which this M1 transistor operate in saturation region. So let us see how can we solve this question. So these are the parameters given in the question that M1 should be operate in saturation region, and Kn value is given at 1 milliampere per volt square. We can see that this diode connected transistor. We have seen in our last questions that if a diode connected transistor is given in the question, then that transistor M2 will work in saturation region. If we want to know that how can we calculate it, then you can see our example one question we have uploaded in this playlist for MOSFET. As M1 and M2 both are operating in saturation region, drain current will be ID1 saturation current, ID2 saturation current, as the same current flows through these two transistors, so it will be equal. Now we put values here. For ID1 we have to assume VGS1 minus VT, and for ID2 we have written VGS2 minus VT. If we solve it, then we can find out VGS2 equal to VDD minus Vx. Here VGS2 can written as this voltage VDD, this voltage, this drain voltage will appear at this gate, so VDD and minus Vx. So we put here VGS2 is equal to VDD minus Vx. VT voltage is given as 1, and VGS1 voltage can be written here, this gate minus source voltage, that is the 2 minus 0 equal to 2. So we put VGS1 is equal to 2 here. From here we can find out equation VDD minus Vx minus 1 is equal to plus minus 1. If M1 is in saturation region, then VDS1 will be equal to VGS1 minus 1. You know that if a transistor is working in saturation region, then condition should be VDS should be greater than equal to VGS minus VTH. Here we can see that this M1 transistor is working in saturation region as it is said in the question. Then minimum condition will be VDS1 equal to VGS1 minus VTH. If this VDS1 voltage is greater than this VGS1 minus VTH, then M1 will act in saturation region. So minimum condition is that this VDS1 should be equal to VGS1 minus 1, as minimum value of VDD is asked for M1 should operate in saturation region. So we have assumed the condition at which this M1 is just going to operate in saturation region, so that is the minimum condition where M1 is going to operate in saturation region. So this condition can be used. Here VTH value is 1 volt, so VDS1 can be written as Vx, and VGS1 voltage is 2 minus 0, that is 2, and minus 1 equal to 1 volt. So Vx voltage will be equal to 1 volt. Now we will put Vx is equal to 1 volt in this equation, then we can find out VDD value is equal to 3 volt and 1 volt. Let us see at which VDD voltage this M1 will work in saturation region. Let's assume VDD is equal to 3 volt, then for M2 we can write as VDS2 is equal to VDD minus Vx. This VDD is equal to 3 volt and minus Vx we have calculated 1 volt, so it will be equal to 2 volt. And overdrive voltage will be equal to VGS2 minus Vx. VGS2 can be written as VDD minus Vx minus 1, as we have seen above. Then overdrive voltage will be equal to 1 volt. Here we can see that VDS2 that is calculated 2 volt is greater than overdrive voltage calculated 1 volt. So this value of 3 volt of VDD, this M2 will work in saturation region. If we check M1, then VDS1 can be written as Vx, as we can see in the circuit. This VDS1 is Vx is equal to 1 volt, and overdrive voltage is VGS1 minus VT. VGS1 is 2 volt and minus 1 is equal to 1 volt. So here we can see that VDS1 is equal to overdrive voltage 1 and VGS2 is equal to 2 volt, which is greater than threshold voltage. So we can see that this is the minimum condition where VGS2 is greater than VTH and VDS1 is equal to overdrive voltage for M1 to operate in saturation region. So in this question we have seen that if we assume that VDD is equal to 3 volt, this VDD equal to 3 volt, then this M2 is acting in saturation region as it should be, since it is a diode connected transistor, and M1 is also working in saturation region when VDD is assumed 3 volt. So VDD is equal to 3 volt is the minimum value at which this M1 transistor work in saturation region. So in this way, we can solve this kind of circuit when region of operation of the circuit is involved in the question. See you guys in next video.